So guys, we'll start the presentation. So thanks again. Welcome to my session. Stop everything top SQL tricks to a developer. Before starting, I want to say that after my session, you should stay here because 10 minutes later we are going to start the raffle where the Xbox will be one of the prizes. So stay here. The slides and scripts are already in my GitHub account. I will also later post my blog, so you can also get the information in there. So, all the speakers, they already told you this, like all over the day. But I want to say again, thank you to all the sponsors for providing everything that we have here today. It's because of them. So if we have here a great location, food, water, it's everything because of them. If you have feedback, anything, you can use the app. Or if you also have some questions, you can just raise your hand. We will try, I will try to answer as many as possible. So, what about myself? My name is Marcos. I am a SQL Server DBA at Zalando. It's a company based in Berlin, Germany. This is my Twitter handle, my email, my blog. So if you want to contact me, just feel free. I would say that it will be easier by Twitter than email. I do answer, but sometimes like it just takes quick. So Twitter is like faster. I am also a SQL Server MVP for about 4 years. Like you see here, I am from Brazil, São Paulo, but I moved to Germany 8 months ago. And I would say that today is like my first SQL Saturday here in Europe, speaking actually. So thanks again for being in this session. So why this session? For me, most of the times as a DBA, you see, I am a DBA, we skip the basics. So we focus too much time on doing difficult stuff. But actually, we should be doing the basics, because if we do it, we can make sure that when we get to a point to do the advanced, we at least covered what we should cover. Sometimes we focus too much on hardware, and we forget the software. So why not adding more CPU and more memory if we can do so? It's great, right? But for how long can you keep like doing that and adding and adding and adding? You don't need to be a master on that. Everything that I will show here to you, you can go Monday on your environment and do it. It's not something that it will bring maybe your application down or it will bring your server down. So it's easy stuff, but you can see that what actually you do here, you can apply easily and get performance. So what I am with this session in the end is that you get better performance on the database, but not without doing much effort on it, because most of the times when we start trying to do a lot of things in the database, it becomes quite difficult. So I want to give you tips that you can actually go and do it. Go and do it. Test it, work it, great, roll out to production. So what is the agenda? I have some items in here. I will try to cover all of them. If there is something that you would like to know, but it's not covered here after the session, or you raise your hand, ask it, or you can come after the session and we can talk about it. The first thing is using the right tools is important. If you don't have any of those, I would recommend to you right now and install in your laptop. So Management Studio, like every SQL Server DBA or every developer that works with SQL Server knows that Management Studio is very important. But one thing that is most important is try to get Management Studio updated, because they are adding many capabilities that it's only available in the newer versions. SentryOne. How many of you know already SentryOne? Great. Do you know also that SentryOne Plan Explorer is free, the full version? In the past, it used to be only the free version with just a few features. Now it's everything free. It's the tool. It was costing in the past, if I'm not wrong, 500 euros. Now it's for free. Just go in their website and download and install. You can see many, many things when you are actually evaluating SQL queries in SentryOne. Another tool, this is more a website, it is Statistics Parser. How many of you know that? Only you? You get a free beer then. Because this is quite surprising, but this guy, Richie Run, he's based in US. He developed this website where you can paste the output from statistics times IO or just statistics time, and he parses that information to you. So you can easily see how many pages were read, how many logical pages, physical pages, read ahead pages, and so on and so on. Another tool which is very important, SQL Query Stress. How many of you know this tool? Oh my God. Okay, so you get a beer, you get a beer, you get a beer. It's also another great free tool released firstly by Adam Mechanic. So his idea in the beginning was having a very simple tool where he could just paste a query and test it. So he could do like some sort of easy performance test against a SQL statement. He stopped maintaining this tool. He released the source code, and now it's available on GitHub. So also take a look. I will show you all of those tools for you during the presentation. But there is also another thing very important. Please try to upgrade to SQL Server 2016 Service Pack 1. Because I think maybe some of the speakers already told you about this, but in Service Pack 1, they actually made a huge change in the product. So mostly of the enterprise features that were really costing a lot of money are now on Standard Edition, Express, Web, and so on and so on. So why not try it? What about if you wanted, for example, try to compress your database? If you are running 2014, you can only do that on Enterprise. But as long as you move to 2016, you can use on Standard as well, but only after Service Pack 1. So it's also a great addition to you. So, going on, the first thing that I would like to talk with you is like about foreign keys and indexes. So, you are developers or DBAs, but mostly of you know that foreign keys are used to link to tables. So basically you have a father table and you have the child one, so you create the relationship between them. So you maintain the database integrity. But something that people sometimes do not know is that you can use them to speed up your queries. You can use foreign keys for doing that. And I want to show you how to do it. So we have here, in the back you can see it? No? Okay, I will zoom it, so I will try to get all of you. The first thing is using wide word importers database. So if you just type database, sample database from Microsoft, that's the new one. In the past used it to be AdventureWorks, now it's wide word importers. So just a sample database that you can play with things. Because this database is like very well designed, I will just drop a few things so I can show to you the behavior. So what we have here, in the beginning I will just drop the constraints that we already have, and I have a very small query. So you are joining orders with order lines, so that you would have probably a foreign key between them, and you are selecting two columns, order ID and order line ID. So, okay, to do that, I'm selecting this table, so you will get results. The first thing that I want to show you, so when I use it set statistics IO on, So SQL Server will output this information for me, like how many pages were read, etc., etc., etc. What I can also do in here is set statistics time on. So if I enable both of them, I have here more information. The first two, you can use statistics parser. You just paste the output and click parse. That's what you have. You have very well detailed how much you are actually spending on each query, for example. So it's not like a life-changing tool, but it helps the developer see actually things more organized, because we just see a lot of lines, and this just to get things easier. Another thing, then you have here the execution plan, and then you have execution plan in Management Studio. But you can also have in SentryOne. If you install SentryOne in the same laptop that SQL Server Management Studio is installed, if you right-click in the plan, you can see it. View with SQL Sentry. So, quite easy. SQL Sentry will just load up and you can see it. So, but the idea is, you have here the execution plan of this query, right? You have a mesh join and you have two scans. Just to keep in mind, when you see that type of join algorithm in SQL Server, probably means that you are missing some indexes, or you don't have any ordered data, and you have like a huge result set which you have to process them. So when you see that, it's mostly because of those reasons. Huge result sets, no indexes, and you could have some benefit from them. So when we actually come here, SentryOne then exposes the same information for us. Also, something which is like very nice is this exclamation point in here, which means something to us. But when you came here, you don't see it on Management Studio. So SentryOne shows more information to you somehow. It could be an execution plan on the XML, but management is not showing, so you can use the tool to show that to you. Okay, so one of the things that we could do it is like, okay, so by default, when you create a foreign key between two tables, so that's one of the things that you should do it, when you create them, SQL Server by default does not index these constraint. So the thing is, you should do that for almost all foreign keys that you have, unless you don't really use that foreign key for any query. But if it's one that you use it, you should index them. So basically you come here, you create the index. So I am creating an index, pretty easy, on the order ID table, on the order line table, in the order ID, and then I create the foreign key. Now, if I execute the same query, now I have a different type of, join. So I have a merge join. This means that we have two ordered result sets, so SQL Server is able to have a better execution plan. Can we see some difference? So let me open another session of the statistics parser. Yeah, you somehow decreased a bit of your pages that you was reading from the database. But one thing here that the foreign key helps us is Because the foreign key is like actually maintained to keep the relationship between both tables. So if you change it just a little bit in your query, SQL Server does not need to check both tables again to check the result of it. So I do have order ID in my order lines table, right? So I don't need to go get that information from my orders table, right? Because I do have a foreign key, SQL Server now only reads from the order lines table. Why? Because there is a foreign key enforcing the relationship between them. And then, what you also want in the end is this. Now, we are just reading one table and not two tables anymore. So this can be some savings for you. But you could say that only the index is doing that for me. So I could disable the check constraint in the database. If I try the same query, now, oops, let me just remove it here. Now I have got the same plan as before. So it's not only a combination of the index and not just a combination of the index and or just the foreign key. It's both of them. So you should, if you use them in a join query, for example, you should try to index as many as possible. So, what we were able to learn at least is that we always should create foreign keys. Remember to create them with check constraints. So if you create a foreign key and use the no check, so the rows will not be enforced between both tables, you actually are not doing anything worth it, at least. And then always also index the foreign key column, only if you are like using in your query. Also, another thing is designing matters. Designing good indexes also matters, right? So you have clustered indexes. So always create them first. Why saying that? Because the non-clustered indexes in your database, they keep on the leaf level the key of your leaf level of the clustered index. So if somehow you had before a heap table, for example, without any index on it, and you had a lot of index no clustered, and you create a cluster after that, you will have a huge series of updates happening in background. Because SQL Server has to update all the non-clustered indexes in your database. So to update the new reflection of the data, how it's distributed. And then you have like those default tips. Avoid them on frequent updated columns, so you don't create huge hotspots. Avoid creating with too many columns. They also impact in the size of your non-clustered key. Remember, every leaf level of the clustered key, the non-clustered key, also has the key column of your clustered. So the thing is, keep them narrow, which means keep the indexes, the clustered indexes key as short as possible. So using, for example, int, which occupies just 4 bytes, for example, small int, tiny int, or if you have, for example, a date column, could be as well. You have 8, depending on the data type, you can have 4 bytes, things like that. Try to keep them short. If that's possible for you, always use growing values. This will help you. Then someone also can say, but then you also create huge hotspots on the data page on the last one, because you always are increasing the last value. SQL Server now has mechanisms to protect that. You will only get this behavior on very concurrent systems. In the majority of them, you don't get it. And then you also have non-clustered indexes. So what is the use case for those? If you have to retrieve a small number of rows, they are very good for that. Also, something to remember is high selectivity, the better. I will show you how can you see what is the selectivity of one index that you want to create. Also, another thing that I want to keep in mind is, because when you create a table at SQL Server and you just create primary key in the column, it creates a clustered index. But not necessarily a primary key has to be clustered. It can be non-clustered as well. Because there are two different things, two different meanings. Primary keys are for enforcing relational integrity in the database. But clustering keys, they are just an internal mechanism for easily finding rows in SQL Server. So you can change them. Not be afraid of doing that. For example, you want to create the primary key on the order ID, for example, but you don't want the order ID to be the clustered key. Can be also another number, for example, order date, I don't know. But you can change that. But you have to change when you create the table, actually. Okay. So, I'm using now the same database, wide word importers. I'm just using statistics.io on, that's what matters for me. What I'm going to do now is creating just an empty table, call it sales order 001, just a new table without any data on it. I have it. Also, something which is quite good, I'm not sure if you guys know, is this new functionality in SQL Server 2016, which is drop table if exists. I know it took a long time for us to have that, but we now have it, so use it. Okay, I have created my table. I will just create now the index key on an order date. Let's say that now the order date will be always an increasing value. So as long as you have orders being inserted in your database, it's all good. But what about if it was modified date, for example? If your order has been modified and then you start choosing this as a clustered key, right? So what do we do? There is a tool that I do like to use it. It's paid, I know, which is SQL Data Generator. This is just for demo purposes. I'm just using a trial. It's like just for generating data load on my database, not other than that. So I have it here. Let me just refresh the schema. Where is, okay. I will just insert 50,000 rows. It's just going to take a few seconds. Do we have any questions so far? No? Okay, good. So while I do create that, I will just move forward and also create a second table. And this time I'm creating a bit different. So I'm just creating the order ID with identity. It's here in the database. So let me just drop it. Create again. Okay. Okay. We have it, 50. 50,000 rows inserted. It took, like, for me, 40 seconds, 48 seconds to insert. So I'm just going back here. I'm not going to select it because I know that I have those a lot of data. Now we just want to check the fragmentation of it. I always forget one thing. Okay, no, this is right. Okay, so here I have the first thing, which is like a high fragmentation because I am just inserting orders in my database. So in this case, it's not like always increasing, it's just inserting random data. So now I can have order date 2017, but the next one could be, for example, from 2016. And then SQL Server has to make space on the data page to insert one after the other because it has to maintain the physical order between them. So what I can do it now, I just alter the index and rebuild it. That's easy, right? It does not cost a lot of time for me in this case. I still have a bit of fragmentation, but that's fine. Now, okay, I have created. Now I will create in the order ID the very same thing. Before was order date. Oops. Now, order date. I'm just gonna insert the same 50,000 rows here. So it's just also going to take a few seconds, maybe less than a minute. Let's just wait a bit. Yeah. Questions? No? Good? Okay. Okay, we have here at least 10 seconds less for inserting the same 50,000 rows. The schema data is the same thing, the columns, the definitions, this very same thing. I just changed the clustering key. And then, if I go and check it, now I have a very different fragmentation in my table because I am always inserting data in the very last page. I am able to get very less fragmentation, so I would not spend a lot of time on rebuilding those indexes. So it will be less cost for me. Another thing that I was talking is like selectivity. So as more the more selectivity that you have, the better. Because of that, let's say I have here two select statements. Just one is like on customer name and the other one is on delivery method ID, right? So if I just execute both, what I will have it. So for the full name, I have 6,663 distinctive values. So if I create an index on this column, it will be very good because then I am able to really filter out my query. But on the other hand, if I create them on my delivery method ID, I just have 3 columns on it. So in the end, I do create an index on it. SQL Server will not gonna use it unless I force it in a int, because it does not make any sense. Why go to the non-clustered index just with 3 possible values if I can go to the clustered base table and look for the same data? So I'm creating them. Now, let me do this query. you. Okay. On full name, here I have like a very big execution plan because there are lots of foreign keys and everything enforced, so it's generating, but what I want to focus is on here. So it's using the index that I have created. Right? But if I change it, so let me do that. Let me just save this execution plan. Let me go back here, let me drop this index. Let me do the very same query. Now I have got an index scan. So just a bit different on what I can see. So I have changing plans. Now let's use the index that I have created on my delivery method ID. Yeah, it is created. Actually, when SQL Server goes to the customers table, it's not looking for my non-clustered key, for my non-clustered index. So it's still going to the base table for it because I have a very low selectivity index. So it's just, I'm just maintaining the index for nothing. I'm not gonna use it never. But I could force it, right? So let's try to compare them. So it's a small difference, right? But I still have it. So 48% doing a scan, 52% using the index seek. So also another thing that this proves to us is like maybe a scan is not bad. Maybe the seek can be bad sometimes. Everything depends on the workload that you have, on the selectivity of the tables, and so on and so on. Another thing that I might have here, which I wanted to show you for the same thing, I have this small database, SQL Set Pro. I just have 3 tables, orders, sales order, customer, sales order header, and person. And then I do a very simple OLTP query, which is I wanted to get the orders for my customer based on my first and last name. And then I have it here, the execution plan. So let me just save this. Okay, I have all the results here. It was just some tips. So, like I was saying, if you can avoid hash joins, you can do so, because usually hash joins, if you have like the top, if you have to create a list, for example, hash joins are the worst one. So they are always using more memory. They are always going sometimes to TempDB to process data. They are, most of the times means that you are processing a huge data set, means that you don't have indexes on the tables, and so on and so on. Merge joins, they are quite okay. Means that you have ordered result sets, it's good. Nested loops is what you want in the end. So the first thing is I'm going to create an index on first name and last name, because that's what I have in my query, right? I look for my customers based on that. So it's great. The first plan was just for creating the index. The second one, now I have an index seek here on the person, first name, last name index. So far so good. It's still showing to me here a missing index. So I'm just gonna select this part, which means for the query itself. But now things start to be a bit different in SQL Server. So when I do this query, so I'm still looking for the first name, but not anymore for the last name. So I just suppressed this information. Normal query. If I do execute, I get more data, maybe I get a different execution plan. I also start to read more data, but I still have C. Okay, that's good. But what about if I change this query? So I'm not looking anymore for first name, but only for last name. Maybe I have this query, I don't know why, but you can apply the same methodology for every other query that you have. But when you actually do this, you now get a scan on the index. Why? Because when you create the index on first and last name is the first key in the index. So SQL Server has to traverse all the index all the way through until the end to find the last name. Because the last name in the creation of this index is the second column. So it does not know where actually SQL Server has to go to find that data. So he has to go all the way through until he finds, okay, now I found the last possible name, I'm good, I return the results. But what we can do is, it's not a feature, but it's just a way to do it, which they call index intersection. So without having one index for two columns, you have two indexes that in the end has the same column. So now I create an index only for first name and now an index only for last name. Now I do for the first name again. I still have it, the missing index. I have an index scan on the first name. But now if I do change the query again, only for query for last name, I get, oops, an index on last name. So in the end you have the same thing. You didn't change anything in your database, but you have maybe more indexes, but you can still use them effectively, right? So, coming back, okay. The other thing that I would like to show you is why store procedures are good. They have many reasons, but I think the most of them would be they avoid SQL injection, right? We always want to take care of not exposing our data, but only if you write the procedure in the correct way. It enables plan reuse. I'm going to show you that. And then you have the optimization of the plan cache in the end. And in the end, it's also good for processing a large amount of data. So instead of you doing that huge select query, bringing the results back to the client and processing in the application layer, most of the times the database service is the most powerful one. It's more powerful than the application server. So why not taking advantage of all that memory and CPU that you have and execute the queries in there? So, I'm using the same database, wide word importers. So it's everything that you can do by yourself. I have here, I'm just gonna clean up the cache. So dbcc free proc cache. You don't want to run this in production because this is just gonna flush all the plans back. And then every single query that you wanna do this, they will have to calculate the execution plan again and start in memory. Sometimes you have, for example, like parameter sniffing or something that it's like causing even your queries to take more time to execute, but in this case, no. So I'm just gonna enable here, and then I have a very simple query, just a few filters, and that's it. I have here how many data pages that I use it, and then I have it here as well, the execution plan. Right? If I do change, for example, the city name, and now I want to look for the sales for another city, okay, I have it, the plan, and I have how much data I was looking at it. But I just gonna open another session here because I want to look for the execution plans that I have in memory only for the wide word importers database. So if you see here, every time that I executed that query with a different parameter, it created a different plan in memory. This can create, on a very concurrent system, we can create what we call cache bloat. So we have a lot of queries being executed, plans getting created, and somehow SQL Server just flush the entire cache because it cannot handle anymore. So what you can do to fix that? You create the very same query, but using a store procedure that accepts a parameter. You didn't change anything else. I'm just gonna clean up again the cache and execute 2 times. Okay, I get the execution plans, 50%, but if I come back here, now I have the procedure in my plan cache, which was used 2 times. And then I start to getting plan reusing, and then spending less memory of SQL Server. So in the end, what you can have is you have less cache being used, you can have more data being in memory. So you still have a benefit. Another tool that I didn't put in the slides, but I have to update that one, is a store procedure that is on SQLskills.com, developed by Kimberly Tripp. If you like performance, you should follow her, which is the SP SQL Skills Help Index. So you just go here, use the schema.tablename. Oops. Here, I always disable that. And then you get an overview of the indexes that you have in your table. Very easy to see if you have more indexes than you need, on which columns they are, if they have columns in the leaf, included columns, and so on and so on. This is free. Just go and find on SQLskills.com. Right? What we can do here is, for example, we can create an index with included columns. We can drop the other index. I can also create an index filtered. So, for example, if you are always, I don't remember which version exactly we have on this on SQL Server. If anyone remembers, you can tell me. But now you have the way to create filtered indexes, which means that, for example, if you have a particular query that always executes with that filter, with that value, for example, and you know that creating an filtered index will help you, you can do it. Just specify a where clause. You can have many cons and pros, so it's the matter of evaluating in your environment. Right? So now I create an index on my city name. So I have it here. Let me include the execution plan again. I have a bit different execution plan now. I'm doing an index seek because it's the filter, but I still have a missing one. Now, if I go back to the previous query where I have not in the store procedure, I can have the same plan. And if I check back again on the plan cache, I have every time that even creating a new index, I'm still using the same plan. So for this case, sometimes what would be good is if you plan to create a lot of indexes in the database, maybe it would be a good idea to flush that plan. You can, for example, in the DBCC free proc cache, you can specify the plan handle and only drop that handle specifically. And then SQL Server in the next execution of the procedure will create the plan again. Okay. So I think by the last, we still have only more 15 minutes. Table variables and temporary tables. Probably a lot of you know that what means those. So table variables, you use them to hold temporary data. No statistics are maintained for table variables. You cannot create indexes. They are much better for small workloads, and you can only refer to them within their own scope. So you cannot access outside the batch of the SQL statement or in another session. On the other hand, you have temporary tables, right? You use them to hold result sets as well, but on the other hand, statistics are maintained. You can create index on them. They are better for handling medium to big workloads, and depending on the creation, they can be accessed before outside the batch scope. So if you create a global temporary table, you can access them in another session, for example, right? So I have another database here, just faking data. But the point here is I want to use that as a small workload for looking at table variables. So I have a query here, returns only 400 rows, nothing much difficult. I'm just gonna flush everything that I have in memory on SQL Server now. And now, what I will do is I will insert some data on a table variable, and then use the table variable to do a join. Okay, you executed that. The one thing about table variables, it's because they are pretty easy to use. You don't need to create indexes. You don't need to do anything. But they are only for, they are better for small workloads. And they have a problem, which is not a problem, but it's done by design, which is when SQL Server creates the plan, the estimation plan for the table variable, you see here, estimated number of rows, estimated number of rows to be read. And if you look above, you have number of rows actually read, which is 23. So it was estimated number 1 and read 23. What is happening? SQL Server is crazy. No. By design, when a table variable is created, SQL Server does not have any data on it. So it cannot measure what will be the result set that you are going to insert on it. So it cannot predict a good execution plan. So it just puts one as the estimation, right? And then, if I change my database here to another one, which I just have like more data, so I have it here, my table variable again. It estimated one row, but it actually read 100,000. So for small workloads, good, but for bigger ones, you might have a very big problem. And then, let me and the problem is, SQL Server will read a lot of data. So you have here 300,000 logical pages in memory. You have here the execution plan always showing a nested loop. And then if you think about it, what I showed before, nested loops are always good for small workloads, but not for like this amount of data, 100,000. They usually are better for when you want to handle small ones. Oops. So the best would be using a temporary table, because if you see here, okay, IO, let me activate the execution plan, let me create the temporary table, and now let me add some data on it. Now you get a totally different execution plan with parallelism and everything else. So, which means that that nested loop in the end was a very, very bad idea for SQL Server, because it was like expecting just a few rows, and it's actually reading a lot more, and then it cannot go back and recreate the plan. So, what you can do, is there a way to force this plan to be in the same way as the temporary table? Not that I recommend you to do that, because then you are adding now query hints, but you can actually do it. If you force the option to recompile, when SQL Server goes to this stage of inserting and data and getting the data from the price adjust, it will recreate the execution plan. And now you have the very same execution plan that you had before with temporary tables. In the end, what I would recommend, using temporary tables, because if you want to create indexes on them, you can still do it. So, but it's for your own testing. As we have just 5 minutes, one important thing is I was showing how to create indexes when changing temporary tables for table variables. But one thing that as me as a DBA I would like to see others doing before going to production is see, are those indexes really being used by SQL Server? Because most of the times you have a lot of indexes in your tables and you don't actually use them. So you are just spending time and space of SQL Server. So there is one index that I always like to use on every environment. If I'm going to do, for example, like a small consulting on someone, the very first thing that I do is, let me see if you have duplicated indexes, because most of the times you have quite a lot. So how you actually do this? There is one database that I know that there is duplicated indexes. We have reported that for Microsoft, but they have never touched it. But on MSDB, you have a duplicated index. So it just shows here to you what the index is, what is the index name, and what is the exactly duplicated index name. And then if you want to drop this index, you can do it, right? But before you do that, what you actually want to do it's the utilization, right? So you have another query that you can use to see how you are actually using those indexes. Because just dropping them does not mean that it will help your environment, but actually knowing how much of space do they hold and how many reads, how many writes, that's what matters in the end. So in the end, what matters is the good indexes always have more reads than writes. That's what matters. Everything else, it's done. So just to keep in mind. And then in the end, you can also see sometimes missing indexes. So you go to the system views of SQL Server, query some tables, and then you have like indexes to create. But something that I also prefer doing, instead of going to the DMVs, I like to do in the plan cache. It's not going to report anything for me now because it's not, I have flushed my plans many times, but I prefer pretty much doing a look on the plan cache than in the DMVs. Why? It's just like my opinion. Maybe you have a different view, but I think you have more a sensitive view of how your environment is behaving. How are your queries being executed? If you want to look for those queries, only the first one, it's from a friend of mine, which is also MVP, but the other ones you'll find, it's from Glenn Berry. It's a very good SQL Server MVP. He has this blog post, this WordPress blog, where he keeps a lot of very good queries for you to query your SQL Server with lots and lots of information. I would still have something else to show, but I don't think we have time. But I have everything on GitHub described step by step how to do it, so I recommend you to take a look on that. If you are looking for more resources, that's what I would like to recommend to you. So first one, if you like performance, Kimberly Tripp, she is very good. Also, Paul White. I mean, if you really want to get deep on performance, if you understand Paul White, you are very knowledgeable. I was never able to understand him. Also, from Simple Talk, Fabiano Amorim, another friend of mine. Benjamin Navarres, also a very good MVP, talks a lot of performance. And the SQL Server performance.wordpress.com, where you can find the Glenn Berry queries for querying your SQL Server database. I appreciate your time. Thank you very much. I will post everything on my blog. The first link is for the session evaluation. I do appreciate your feedback, if it's bad or good, but it will be good for me to improve the presentation. So thanks again and have a good day.